Hello class, this is Colin, and video is going to look at the interpretation of the results that we just calculated on the factorial ANOVA in Jasp. So first, let's talk about the assumptions of a two-way or factorial ANOVA. We are assuming that each cell contains an independent sample. That means we're not measuring multiple individuals in different conditions. They're all set to one specific condition in this experiment. We're also assuming that the dependent variable, in this case the anxiety scores, is a measure that's normally distributed interval or ratio scores. And lastly, we're assuming that the populations have homogeneous variance. That means there's equal variance across the different conditions in this experiment. I didn't go over this in the last video on Jasp, but if you are interested, you can pull up assumption checks in the ANOVA menu and click homogeneity tests. This is going to bring up Levine's test for the equality of variances, and we can look at the p-value here, which is higher than 0.05, and reject the null hypothesis. In this case, that means that there is equality of variances across those conditions, so we can continue on with our interpretation. The first step in our interpretation is to look at the main effects. So we are going to look at the effect of gender and see whether there's a difference in the levels of that factor. So right away, looking at these means of 3.48 and 3.88, we can see that there's not a big numerical difference between those, but we don't know that's significant until we look at the results of the test. So looking at the F value for gender right here, we can see that we have a value of 0.9 and a corresponding p-value of 0.35. So that's higher than our test value of 0.05. So we're going to fail to reject the null hypothesis, indicating that the difference between 3.48 and 3.88 is not significant. The second main effect that we're going to look at is that of drug condition. And we can look at the marginal means for that down here. So we have 4.88 for the control condition and 2.48 for the anti-anxiety condition. And when we look at the p-value for this, the F value and the p-value, we have an F of 31.41 and we have a p-value of 5.57 e to the negative 7, which means in scientific notation you would add in 6 zeros before this value here, so it's going to be a very small p-value, much smaller than our test level of 0.05, and we're going to reject the null hypothesis, accepting the alternative hypothesis that the differences between 4.88 and 2.48 are in fact significant. So we have a significant main effect for drug condition. Lastly, we're going to look at the interaction between gender and drug condition. And we'll go over the marginal means for that in just a second, but by looking at the F value here of 0.16, which is pretty small, and the corresponding p-value of 0.69, we're going to fail to reject the null hypothesis. This p-value is not smaller than 0.05. So we're assuming that there aren't significant differences between the conditions in the interaction. So by looking at these marginal means results over here, we can construct a table that might help us interpret these results a little bit more simply. Remember that the main effects are collapsing across the levels of the other independent variable. So when we're looking at the independent variable of gender, we're only looking at males and females in this study. We're collapsing across the independent variable of diagnosis between the control or anti-anxiety drug conditions. So the main effect of gender, remember, is testing between this value of 3.48 and this value of 3.88. The individual cells here are the marginal means conditions, so we can see that for males in the control condition, they have a marginal mean of 4.59, and in the table we find that same value. Males, control condition, the value is 4.59. So just by looking at this table, we can assume that there might be some interaction effects. It seems like there's some pretty large differences, or sorry, that there aren't interaction effects, because we can see that when we look across males and females, the values tend to be the same within the within the independent variable levels for gender, 4.59 and 5.17 are not particularly big, and when you look at them in the collapse conditions, we already know that 3.48 and 3.88 are not significantly different. However, for the independent variable of diagnosis, we have 4.88 and 2.48, which we know are significantly different. So let's look at a potentially easier way to interpret these results, which is getting a descriptive plot of these conditions. So here is a descriptive plot. This is the one that we produced from Jasp, and this is one that has just been labeled. And we can see once again the conditions of the marginal means. And because there is no these lines are parallel to each other, we already know that there's not really going to be an interaction effect, right? When you see crossed lines in a descriptive plot, that's telling you that there's a combination of effects. There's variance across two factors of your independent variables. And we can look at this simple chart here and use this to interpret our results. So we can see that in the control condition, anxiety was much higher than in the anti-anxiety drug condition, but that when you look at males and females, that their results tend to not change in the same way that there's a massive change between these two levels of the drug condition. So that is the simple interpretation of these results. You'll also notice that I didn't go through any post hoc results. That's because when you only have two levels in a independent variable or in a factor, you don't need to run post hocs because any differences that you have are coming between those levels, so you don't need to run a Tukey's or Bonferroni test. And that is everything for your interpretation. Thanks.